right, so all of the trig functions we have now. Sine and cosine is what we've been doing. SOHCAHTOA. We need to know SOHCAHTOA in case we are given a triangle with sides that are not on the unit circle. If it's on the unit circle, we have talked about sine is equal to y. Cosine of an angle is equal to adjacent over hypotenuse, or if it's on the unit circle, it's equal to x. That's what we've been doing since 1.2. Yes?
You want us to memorize the right side for the test?
We have to know everything. From 1.1 through 1.8. You have to know it all.
On the right.
I mean, yes. You have to know it all. Anything that we've done on notes and homework, you will have to know for the test. Tangent, so that this SOHCAHTOA is what you've known before. Opposite over adjacent. If it's not on the unit circle. If it is on the unit circle, we think of it in terms of sine and cosine. Tangent of an angle is equal to sine of an angle over cosine of an angle. Sine of an angle is equal to y. Cosine of an angle is equal to x. So when we have tangent of a value on the unit circle, we think of it in terms of x and y. If it's not on the unit circle, we think opposite over adjacent. Okay, so you have to know both. This doesn't just go away now that we know x and y, because not all numbers are on the unit circle. Only multiples of 30 and 45 are on the unit circle. So those are the kind of regular trig values. Then over here we have their reciprocals. Now, when you say the opposite or the inverse, I'm going to correct you. Not because I'm trying to be rude to you, but I want you to say it correctly. If you can say math things correctly, it's a lot easier to remember them. Okay, so again, I'm not trying to be mean at all, but if you say, oh, cosecant is the opposite of sine, that's not true. Opposite means positive and negative. Inverse, we have a whole unit on inverses. Unit 3 is all about inverses. We're not there yet. These are called reciprocals. Reciprocal means numerator goes to the denominator, denominator goes to the numerator. So cosecant is the reciprocal of sine. If we flip sine, sine theta over 1 becomes 1 over sine theta. If we take the opposite over hypotenuse, that flips the hypotenuse over opposite. Or if we're on the unit circle, we take y, flip it, that's 1 over y. So different ways to think about it. We have to know all of them because it depends on the situation which one we will use. Secant, reciprocal of cosine. 1 over cosine and secant are equal, which is adjacent over hypotenuse becomes hypotenuse over adjacent, x becomes 1 over x. And then cotangent is the reciprocal of tangent, so cotangent, 1 over tangent. Opposite over adjacent becomes adjacent over opposite. Sine over cosine becomes cosine over sine, which becomes x over y. The x's and the y's are what we use when the angle given, whether it's degrees or radians, is on the unit circle. If it's not on the unit circle, then that's when we use our SOHCAHTOA, and then the reciprocals. All right, I'm going to do the calculator part last because I think it makes more sense to do the non-calculator part first. So we're going to do the non-calculator, and then we'll get to the calculator part at the end. These next three, just review from yesterday. How do you find the reference angle? Some of you can look at that and know the reference angle without even thinking about it. You have to be able to do these without a calculator. If you can't add and subtract without a calculator, you need to do some practice. So I'm going to show a little bit of work. It's not necessary to show work, but 285. So this is 0, 90, 180, 270. So 285, there's your 285 angle. We are looking for the reference angle. So there's our reference angle right there. If you know how far it is from 285 up to 360 in your head, terrific. If not, you do 360 minus 285. Again, this would be a non-calculator problem, so if you forgot how to subtract, there's a little lesson on it. Borrow 1, bring 1 over, so 5. You need to borrow another one, 75. So there's your answer, 75 degrees. Don't forget the degree symbol. So 75 degrees is the reference angle for 285 degrees. 235, we do the same thing. If you need to draw a picture. No need to draw a picture, no need to show work. Completely up to you. So 235, 0, 90, 180. So there's 235 degrees. We need to know what this one is. Now what I would do on that one is I would think, okay, 235 up to 200 is 35 plus another 20 and get 55. Or 235 degrees minus 180 because we're in quadrant 3, all from yesterday's notes, and you get 55 degrees. Yes?
Reference angles was attached to an x-axis.
Correct. So that's from yesterday. Looking through that definition from yesterday for reference angle, an acute angle, where terminal side goes back to the closest x-axis. Okay? Always attached to the x-axis. Again, that's all definitions. So when you're studying for your tests and quizzes, look at those definitions. Know those definitions. You know the definitions, it makes everything much, much easier.
On that 235 one, would you also accept 135?
It's not acute. Must be acute. So a reference angle must be acute and positive. So it has to be between 0 and 90. All right, 115. Again, if you can just write the answer, fine. I do not have to see work. Here would be 115. Reference angle, terminal side to the closest x-axis. The closest x-axis, that is always going to create an acute angle. If you go terminal side to the closest x-axis, you don't have any choice but to create an acute angle. It will always be acute, and reference angles are always positive. So here we would do 180 minus 115 and get 65 degrees. So if you need to show those steps, show that work. If you don't, that's okay too. So just kind of a reminder from yesterday, reference angles. All right, this one is similar to what we did a few days ago. So a few days ago we said, what was the problem? The sine of theta equals 3 over 5, and it is in quadrant 1. So we went to quadrant 1, we drew our triangle. 3, 4, 5 was a Pythagorean triple, so we could label it. And it said, what's the cosine of that angle? Well, now we're doing all of them. Obviously, if you're given 1, there's 5 left, there's 6 total trig values. We already are given 1. Now, knowing what we know about reciprocals, are there any of these we can answer without doing any work, just by looking at this? Sine, because sine is the reciprocal of cosecant. So we can go right to flipping those, and we get negative 15 over 17. We don't even have to think about anything for that one, because we know the reciprocal of sine is cosecant, and then vice versa, the reciprocal of cosecant is sine. Now, for the rest, we do have to do a little bit of work. So it gives us this trig ratio right here, and then it gives us this information. This is another way, a little bit fancier, more mathematical way of saying what quadrant it is in. It is very important that you put it in the correct quadrant, because it's going to affect all of the signs, the plus and minus signs of your answers. So the best thing to do is take these outside terms and label. Where is it? Here's 0, here's negative pi over 2. Because every trig value, 2 quadrants it's positive, and 2 quadrants it's negative. It has to specify which quadrant. If not, we have too many answers, so it will always tell you what quadrant to be in. This is another way of saying we are in quadrant 4. We must be less than 0. We must be greater than negative pi over 2. So that means we are in quadrant 4. So that's where we will draw our triangle with our theta being the reference angle right there. I will tell you that in the past 5 or 6 years I've taught precal, if people draw their triangles in the correct quadrant and do not label them correctly with the correct plus and minus signs, typically that transfers to the answers. And then something that seemed very easy is all wrong because you got all of your signs mixed up. draw it in the correct quadrant. Draw a little x and y axis and make sure the triangle is in the correct quadrant so you can get your signs correctly. Correct. All right, so now we can use that cosecant or sine, whatever we want, because remember this is hypotenuse over opposite. So we can go ahead and label this triangle over here. So the opposite is 15. Hypotenuse is 17, but one of them has to be negative. 15, very good. And that is a triple. Anyone know it? 8. Good. If you don't know it, you just have some multiplying to do. 17 squared plus negative 15 squared, or equals 15, negative 15 squared plus x squared, or a squared, b squared, whatever letter you want to use. So now we can answer all of those questions very easily if we know our SOHCAHTOA. I always start with the 3 regular ones right here. Cosine of this angle is adjacent over hypotenuse. So 8 over 17. Because we know secant is the reciprocal, all we have to do is take the cosine to make it the reciprocal. 17 over 8. And then TOA, tangent of the angle is opposite over adjacent, so negative 15 over 8. And then the reciprocal of tangent is cotangent, so negative 8 over 15. Now, we do not like to see negatives in the denominator. Okay? Negatives should not be, you shouldn't have ones in the denominator, you shouldn't have negatives in the denominator. It's not a completely simplified version of the answer. You can have the negative out in front or up in the top, because even though the 15 is negative, once we do the ratio, 15/8 is negative, or 8 over 15 is negative. Okay? It's not the 15 only, it's that value is negative, because it's the ratio of those two sides. So the value 15 over 8 equals something, 1.789 something, and that number is negative. Questions on that one? Okay, so there we had to use our SOHCAHTOA because 17 and 15 was not on our unit circle. The size was given. Now find the exact value or state undefined. It tells you what to state if it's undefined. Don't make up your own word when the directions tell you the word to use. Use the word the directions ask you to use. Do not make up your own, because while there could be other words not defined to be correct, but you making up different words is not going to always be correct. So, cosecant of 225. Now we're back on our unit circle. So we're going to use that unit circle to evaluate these. So when we look here at our unit circle, we go to 225. So here's 225. These are the coordinates that happen at 225. So I'm going to draw that over here. So here is 225, and it's negative root 2 over 2, negative root 2 over 2. All 3 of these deal with 225. So those are the only values that we care about. Cosecant of 225, since it's on the unit circle, we don't have to worry about SOHCAHTOA and reciprocal. We need to worry about the x's and the y's. So cosecant is 1 over y. Or it's the reciprocal of the y value. So sine, if I said what's sine of 225, that's going to be the y value, which is negative root 2 over 2. If I want the reciprocal of that, all I have to do is look at that y value and flip it. Negative 2 over root 2. That's all I have to do. I could say negative 2 over root 2, and there's your answer. Now, if I think of it that I have up there that it's 1 over y, and that's not what I did. Okay, so 1 over y is equal to negative root 2 over 2. Fractions and decimals and fractions are never okay. It is not simplified. It is not a correct way to write a number. Do not ever leave an answer with fractions or decimals and fractions. I will count it completely wrong every single time. You can't divide fractions, So you have to multiply by the reciprocal. 1 times negative 2 over root 2, negative 2 over root 2. So all you have to know is it's the reciprocal. Cosecant, if it's on the unit circle, go to the y value and flip that y value. Secant, go to that value on the unit circle, go to the x value, flip the x value. Almost every place except the quadrantals, it is a fraction or a ratio. Do some of you want to rationalize that because you don't like that radical in the denominator? That's fine. Multiply by root 2. You get negative root 2, negative 2 root 2 over 2. Now, if you leave your answer like that, now you're minus 1 because you haven't simplified. So because you rationalize, now it creates a simplifying problem, so negative root 2. These are exactly the same answer. This is an unsimplified version. Okay, that is unsimplified. That would not be full credit. Full credit, full credit. You decide to rationalize, that becomes a simplifying problem, you need to simplify.
I don't understand how you just
I did it. I multiplied. 1 times negative root 2, 1 times anything is 7. So I didn't take it away, I multiplied by 1. I can't divide fractions, so I multiply by the reciprocal. 1 times the reciprocal of the denominator, 1 times anything is itself. Okay, so I originally had 1 over root 2 over 2. The reciprocal became 2 over root 2. This is root 2 over 2. I had to multiply by the reciprocal. The 2 came to the top and the root 2 came to the bottom. So again, I didn't just get rid of the 1. I multiplied by 1. And multiplying by 1 results in the same number.
Then why did you do the reciprocal?
Because I can't divide fractions. Dividing fractions means you multiply by the reciprocal. This will never be okay. I will count it completely wrong every single time. You cannot have fractions and fractions. You can't have fractions and fractions. You can't have decimals and fractions. Ever. You get it be correct. You can't. You don't want to be correct. I will count it wrong every single time. So don't do it. Alright, tangent of 225. We're still at 225. Tangent, TOA, fine, but we're on the unit circle, so we need to think in terms of x and y. Y over x. Y is equal to negative root 2 over 2. X is equal to negative root 2 over 2. Doesn't even matter what those numbers are. It's something over itself. Yes, whoever just said 1 is correct. 1. Anything divided by itself is 1. The signs are the same, so it's positive. If the signs were different, then it'd be negative. Back a couple of sections ago, all Scots take calculus. All are tangent. Down here in quadrant 3 is positive. Okay? Or just remember your signs. Negative, positive, negative, negative, positive, negative. Since the x and the y are both negative, our answer is negative. Cosecant is the y value. Y value is negative. So that is another way how we know at least the sign is correct, the plus or minus. All right, then secant, 1 over x, or just the reciprocal of x. So we go to the x value, take the reciprocal, equals negative 2 over root 2. Secant and cosecant are the reciprocals of the x and the y values on the unit circle. So just go to that x value and find the reciprocal. No need to do all of that math. You can just find the reciprocal, and all the reciprocal is numerator goes to denominator, denominator goes to numerator. All you're doing. All right, tangent of pi over 2. Pi over 2 is on our unit circle, so we're going to think in terms of x and y. Y over x. So we look up here. There's pi over 2. Y is 1. X is 0. So that is 1 over 0. That 1 over 0 is not an acceptable answer. That would be undefined. The directions told us what to write. Find the exact value or state undefined. I'm going to do what the directions ask me to do. Abbreviation is fine. UND, I don't care if you abbreviate. UND or write out undefined. Secant of negative 3 pi. That's 1 over x. Again, we're on the unit circle, so that's why I'm thinking in terms of x and y. That first problem, I was not on the unit circle, so that's why I did my SOHCAHTOA. So negative 3 pi is over here. Remember, all even integer pi, positive or negative over here. Odd integer pi's, positive or negative over here. So that could have been negative 3,431. We're still doing the exact same problem. Odd is on the left, even's on the right. This is the point over here, negative 1, 0. Secant is the reciprocal of x. So if we take the reciprocal of negative 1, reciprocal of negative 1 is negative 1. Or we can plug in x right here, 1 over negative 1 gives us negative 1. Never leave a negative in your denominator, never leave a 1 in your denominator. Don't tell me 1 over negative 1 or negative 1 over 1. Don't tell me the square root of 1. The square root of 1 is 1. Don't leave the square root of 1 in your answer either.
How did the x just be 1 over 1x?
X equals negative 1. Right here. Anytime you find these, it'll always be a value. Okay? And how do we can find that? Find the exact value. Okay, so you know right there with the directions that you're going to have a value, some kind of number. Other questions on those? Evaluate. All right, now let's get your calculator out and look at these. Now, just a reminder, second plus 7, we're going to clear your calculator. It is going to default to radian. I'm going to tell you that over and over and over again so that you don't forget it, because every year there's a handful of people who get 10 or 15 points off on a test or quiz because their mode was wrong. Don't be one of those people. Okay? Always check your mode. Only time the mode matters is when you're pressing one of these buttons, sine, cosine, or tangent. This first one is in degrees, so I'm going to move my 2 degrees. And this first one's easy. Tangent 105. Enter. Here we get our answer. There's a tangent button. Super easy. We could all do that without even any teaching. Now, cotangent, cosecant, and secant, there's not a button on your calculator. Okay, you can't try to find it. Try to find it, but it's not there, so no need to look. We have to use this right here for the calculator. That row right there, that's what's going to help us put it in the calculator. Now, could we do number 2 without a calculator? Absolutely, but it's on the calculator section, so I'm going to show you how to do it in the calculator. Because it's 30 degrees, because it's on the unit circle, it'd be one we could do without, but we're going to show it in the calculator. All right, so right above, look, it says cotangent of an angle equals 1 over tangent of an angle. Says that right up there in that chart. We don't have a cotangent button, but we do have a tangent button on our calculator. So we need to use this when we're using our calculator. In this case, the angle is 30, so cotangent of 30 degrees equals 1 over the tangent of 30 degrees. Because in this case, theta is 30 degrees. Theta is an angle, whether it's degrees or radians. How do we know degrees or radians? If there's a degree symbol, it's degrees. No degree symbol, it's radians. Yes?
So since 30 is on the unit, so we can't just do...
You can do this one without a calculator. We're doing it with. So this is what I would put in the calculator. I need to be in degree mode. 1 divided by tangent 30 equals. Here's your answer. If you don't look at this till you get the test, most likely is you're going to forget how to put it in. And you're going to say, I don't know how to put this in. And I'm going to say you have to know that. What the test is. You know what you're doing. So 1.732. Once again, This one could be done without a calculator because it's 30 degrees. If it's on the calculator section, the directions say round to the thousandth, so that's what I'm going to do. I'm going to follow the directions, always. Always, always follow the directions. If this was a test question and you said, do I round to the thousandths? I would say, follow the directions. The directions and see what they say. Just do what the directions tell you to do. Always work. Now, 3 and 4 do not have a degree symbol. If they do not have a degree symbol, that means it's in radians. So, looking at your chart up there, cosecant of -1 is the same as 1 over sine of the angle. Cosecant of an angle equals 1 over sine of that angle. Now, when you're typing in the calculator, be sure you type it in correctly. I will tell you, in 19 years of teaching, a calculator has never given anybody a wrong answer. That doesn't mean you haven't got the wrong answer using the calculator, okay, but you have to type it in correctly. The calculator doesn't know what's on your page, it just knows what you type in. For example, negative and minus signs. So if I typed in 1 divided by sine, and I used -1 instead of -1, it's going to say an error. That happens on a test or quiz. I will not help you. I'm going to say you have to know what to do. Calculator's not broken. I messed up. Calculator didn't mess up. I messed up. But what you can do sometimes is, look, it gives you 2 choices. Do you want to quit or you want to go to? Well, I don't know what I did wrong, so I want to go to where I messed up. So I hit number 2. It tells me, it goes in flashes right where I messed up most of the time. Now, if you do a bunch of stuff, it's not going to like go everywhere. But a lot of the times, it will go to where you messed up. I typed in minus instead of negative, fix it, and now I have my answer. That is not right. Gradient mode. -1.188. So notice, if you go in the wrong mode, like I did right there, I made 2 mistakes. I did a minus, and I didn't change the mode. My answer was very wrong. Okay? -1.188 is your answer. And then here, secant of an angle equals 1 over cosine of that same angle. So 1 over cosine of 50, you should get 1.036. So that is how you put the reciprocals, not inverses, not opposites, they're called reciprocals. We are going to do opposite, we do opposite every day, reciprocals, and inverses. They are all 3 different. They're not the same.